Okay, in this lecture video, we're going to look at our third type of inhibitor, which is mixed inhibition. And mixed inhibitors are just what they sound like. So now we're talking about an inhibitor that is not just selective for the enzyme substrate complex. However, it still binds to an allosteric site, a site that is not the active site. So in terms of our schematic, enzyme plus substrate goes to enzyme substrate complex, goes to product. The uncompetitive inhibitor could bind before the substrate does to form a complex. Then the substrate could still bind, and you would end up with a ternary complex of the three. However, it's still not going to be catalytically able to do its job. The enzyme won't. Or you could have the inhibitor bind after the substrate and still end up with the ternary complex. So what we're looking at here is an inhibitor that binds to a site that is important for both substrate binding and catalysis. It has multiple pathways for inhibition. Therefore, the effect on the rate equation is a mixture of what we saw for both competitive and uncompetitive inhibition. So now, in terms of how our Michaelis-Menten equation is modified, we've got an effect directly on Km because it's like binding with competitive inhibition, and we've got the effect that we saw for uncompetitive inhibition. So on our double reciprocal plot, if we were to make that, we would again see a different pattern in terms of how that plot changes in the presence of inhibitor. We would see something like this. So again, this would be experiment 1, no inhibitor present, experiment 2, and experiment 3. We're going that way. You're increasing the amount of inhibitor that you've added to that particular reaction. So when we look at this, we see changes in the intercept, right, on the y-axis, which is 1 over Vmax. So we see now if 1 over Vmax is increasing as we add more inhibitor, then that means our Vmax in this case is going down. We also see now that our Km is also changing as we add the inhibitor. The 1 over Km value is going down, which means our Km value is increasing. This is a little bit different, again, than what we saw with our uncompetitive inhibitor. We saw a decrease in both Vmax and Km. In this case, Vmax is still going down, but our Km is going up. So if we wanted to look to see how those values were changing, our new Vmax is going to be Vmax over alpha prime. That's what we saw with the uncompetitive inhibitor and its effect on decreasing Vmax. And our new Km value in the presence of inhibitor is going to be a combination of what we saw, alpha Km over alpha prime. So now we've gotten 3 different scenarios, 3 different types of inhibitors, competitive, uncompetitive, and mixed, and 3 different effects on the combinations of Vmax and Km.